Hey, so we are Eric and Martin, and we have a couple of jobs in GitLab that we need to run. Up here and there. And as you can see, they are stuck. They are waiting on a dot that just doesn't exist, a test machine that doesn't exist yet. They are here, and let's get started because, well, we need to run these jobs. We have 10 minutes to tell you how good CI-Tron is. Here we go. So what is CI-Tron? It's a bare metal infrastructure that has been designed for people who are under some stress, as in, like, you need to maintain a farm, so you're under stress. We want to avoid a situation where, like CrowdStrike, where the machine just doesn't boot anymore reliably. Oopsie. So we are image-based and fully net booted over HTTPS, so even the boot configuration is stored outside of the machine. It's auto-configured where possible for pretty much everything, everything that we could, and that also includes backup and dot configuration. Then for the actual test machines, we aim to be easy to use and very low maintenance. So for this reason, we are also container-based. So everything is loaded, cached, and run by boot to container and initram FS that we developed. That is Podman-based. We have sane defaults. That means that by default, the machine is just going to boot and run what you want. But of course, if you want to have more control, then you can partially override these defaults or fully. And also, we don't have any hard-coded boot flow, and we're going to talk about that a bit later. Okay, so here is the boot sequence of the gateway. So it's going to be a bit easier to see. So first thing, iPXE is a bootloader, is loaded from a USB stick. It downloads the boot script and artifacts from a remote server, authenticated by a client certificate inside iPXE. Then the kernel boots and run boots to container. Boot to container downloads and run the gateway container. Then we have the systemd logs that you saw for a split second, and then the dashboard appears. And this is your CI-Tron dashboard.
Okay, so enough about the gateway. What about the DOT? Or the test device?
Go ahead.
So for the test machines, we have some requirements on the hardware side. We support x86 64-bit, ARM 32 and 64-bit, and RISC-V 64-bit. We need to have fully controllable power switching, even the battery. So on Steam Decks, for instance, we need to do some modifications for that. You need to have Ethernet network. On some devices that don't have that, we use a USB gadget. And we need a serial console for the real-time logs. On the software side, we support on Android, the Android bootloader, EFI, iPXE, and Raspberry Pi or U-Boot. And for the kernel, out of the box, the device is going to be supported out of the box if it has upstream Linux support, and otherwise a recent-ish Linux is enough. So let's assemble the DOTs. So Martin's going to set up everything, each machine one at a time, and I'll explain the boot flow. Yeah. So first off, we have the Steam Deck. So we use a smart plug to control the power remotely. And it's connected on the battery relay. We plug the network and serial console I'll have that. And in a bit, we'll press Discover on the dashboard, and it will turn on the PDU port that he just showed, and CI-Tron will wait for a new device to appear. This will happen with iPXE that is going to announce itself with a DHCP request with the user class option, which provides the client architecture as x86 64 UEFI TFTP as the parameters. From that, we're going to enter. The configuration here is for DHCP requests with called iPXE, which matches an iPXE request of one of those architectures. So for this, We're going to answer with this boot script from a URL. That's this tiny script that we have here with just a kernel and init.ramfs, which are configured here. Those are the default options, but the job can override those. And it's just going to boot that. And yeah, once it's done with the discovery from that DHCP request, it's going to go in training to make sure that it boots properly. Next, we have the Raspberry Pi 5, again on a smart plug, but this time we were booting an ARM64 machine. But unlike iPXE, the Raspberry Pi firmware does not always identify itself. Instead, we have to rely on detecting the MAC address here, and we have this list of MAC address that we sort from the OUI allocation. And yeah, so then next we just download the, sorry. Yes, we download the board setup, the DTB device tree, the kernel via TFTP. We have too many files to expose, so what we do instead is that we download the whole firmware from the Raspberry Pi repository, and we extract the files to, no, sorry, here. We extract these files and we expose them in the correct path so that it can actually boot with these files. And the job can override that or just use that and add something on top. Next, the Vision 5. Martin went faster than me. This one is a bit of a simpler setup, but we're using a power over Ethernet switch to provide both power and network together. And this one is a RISC-V board. Last one is an Android, and this one we use fastboot to boot it, which is different. It's not a network request; it's a new USB device that pops up.
Yeah, and now here is the dashboard. Oh, maybe I could make it a bit bigger by closing that. Here we go. Yeah, so what you can see there is that now we have, oh yeah, sorry. That's probably better. So we have detected all the hardware. So we have the Van Gogh here, which is the Raspberry, the Steam Deck. And we can get information about the Steam Deck up here. So we see that it is a 4-core CPU, 16 gigs of RAM, booted using EFI. We can see the bar size, PCI ID, of course, and then the AMD GPU information about it. And that's it. So we have that for every single dot. And it was learned by booting a container that was just checking what is the actual machine that was being used. Then, yep, what do we have next? So we want to expose these machines on GitLab. So what we need to do is say which instance we want to expose it on. Then what type of runner we want. Is it an instance runner, a group runner, or a project runner? We'll need to create a registration token that has this create runner role. And if you want it as an instance type, then you need to have the admin mode also. And then you need an access token with the read API role that allows you to check that the tags that are in GitLab are the same as the ones that we have found. And then you just have a way to expose the runner if you want or not. Very good. Then we can run interactive jobs on it. We don't really have much time for it, but the way you do it is first you connect to the farm using WireGuard, and that means that if you have multiple farms, then you can connect to all of them. Then you just run this command, execute a CTL run. Then you set the tag that you want to use, one or many. you set a folder that you want to, like all the files that are in there are going to be uploaded to the DOT or test machine. And then all the files that are going to be added there by the test job are going to be downloaded back after the execution. So at this point, like you would have all the files from the job. Yes. So actually, now we probably should have checked first the jobs. So GitLab, yes, it's started, and it is right now pulling the containers. I don't know how long it's been running for. 3 minutes, okay, and then it started testing VKD3D on the Steam Deck in real time. And then we have the Raspberry Pi. Hopefully also has picked up the job. Yes. No way. Everything has been working? There's no way. Look, it's done. It's been running VKCTS. I mean, the fraction is 1,000, so, you know, pretty fast, but here it is. Up. 999. This is not what I wanted. Okay. So yeah, now you know that you can also run interactive jobs. And now comes the question, like, why did we decide to spend so much time on CI-Tron? Well, that's because we want to make it possible for developers to share the test machines and do it without feeling like they could destroy their setup and rootfs or like change a variable somewhere and then you don't know like what is your boot configuration. So it's terrible. So we want to get rid of that. We also want to obsolete installing and maintaining OSs on your test machine, because we just, every single boot we send an init from FS that is the OS to run your container. And it's fine. It's just 20 megs, so it really doesn't take much space. And yeah, and of course, being able to run a CI system like this in a hotel room or in a venue here, it's fine. See, no problem. Wasn't stressful at all. So what's next? A ton of things. That's not even full. That's all we could think of. But I mean, the gist of it is that we have a lot of features that we want to add that are going to be impacting the design, especially job prioritization and preemption. You know, if you have a long-running job running traces, then you want to be able to run your, well, pretty much jobs from Mesa instantly and then continue the low-priority tasks. So these sort of things are going to be changing a bit the interface, and hopefully we can settle this soon, and then we can have, you know, more people using it. So that's the gist of it. And yeah, that's it. Here are our contact information, and we are, I guess, done, because it's not a talk, it's a demo, so I don't know if there are questions. Thanks for listening to the rambling.